Okay, ladies and gentlemen, welcome back to Math 30-1, Chapter 2, Section 4, Part 2, Sketching Graphs of Rational Functions, Notes. Now, I've moved on to page 4, example number 4. Now here's where it takes a left turn into uh-oh, so you have to understand the theory behind it. Now you look at this, y equals x squared plus 2x minus 3, and your denominator, x plus a. All of a sudden there's a second variable in there. You can't graph it. Or at least you can't graph it with your graphing calculator. But I can ask you several questions about it. First and foremost, what is the x-intercepts? Well, with the x-intercepts, y is always 0. So 0 is equal to x squared plus 2x minus 3 for x plus a. And what do you do with your denominator? Well, you multiply both sides by x plus a. What happens? Down to 0 is equal to x squared plus 2x minus 3. The question you have to ask yourself, can you factor that? Well, yes you can. Go back to the hints I gave you about factoring. Think about them. This is a simple quadratic. What two numbers multiply together to be minus 3 and add together to be plus 2? X plus 1, x plus 3, sorry, times x minus 1. Now, if you have trouble with that, grab your graphing calculator, plug in the equation, x squared plus 2x minus 3, and you will get 0 at minus 3 and plus 1, and you should be able to turn that into x plus 3 and x minus 1. Now, here, x plus 3 is equal to 0, minus 3, x equals minus 3, x minus 1 is equal to 0, plus 1, is equal to 1, just as I found on the table of values here. But I started factoring in my head, so I wanted to be consistent. So I've got a couple of x-intercepts. Now, my y-intercept, x is equal to 0. So this is y is equal to 0 squared plus 2 times 0 minus 3 over 0 plus a, which is minus 3 over a, and we're kind of hooped because we don't know what a is. But I do have a y-intercept, and I can talk about non-permissible values of x. Notice, can't graph it. So, denominator x plus a cannot equal 0. Subtract a from both sides. X cannot equal minus a, whatever that is. And your vertical asymptotes. Well, x equals minus a, whatever that is. Now notice I keep talking about non-permissible values of x and vertical asymptotes. Take a good look at that. We don't know what the numbers are. All we can say it's minus a. And remember, I could ask domain. X is all real, except x cannot equal minus a. Now, as for horizontal or oblique asymptote, well, it's y is equal to x squared plus 2x plus a. You'll notice there the numerator is a higher power than the denominator, so it's not horizontal. It's going to be an oblique asymptote. So, oblique, remember the hint I gave you? The easy way to do this, x goes to infinity, and you look at just the highest powers. Oh, what am I smoking? Hang on, sorry, no, that is horizontal. Oh dear, oh dear, oh dear. I hate this getting old. With oblique, you have to do synthetic division, but you cannot do synthetic division because you don't know what x plus a, or what a is. Nor can you do behavior of the graph near the asymptotes. And we're pretty much stuck there because not much else we can do. So, note here, you have to know the theory. Now that was an easier one. I'm going to give you a minute to look at this. When you're ready, go on to a harder one. And here we go. Number 5. Y equals x minus b over x squared minus b squared. Now what can you do with this mess? Well, there's a couple of things. We can factor, because this is a difference of squares, x plus b for x minus b. And this simplifies to 1 over x plus b. Now, if I do that, note my x minus b is cancelled out, so x minus b cannot equal 0, plus b. So I have to make a note here, x cannot equal plus b, or x cannot equal b. Now, my x-intercepts, well, y is equal to 0. So 0 is equal to x minus b for x squared minus b squared. Now, some of you are going, actually I'll stop for a moment, let you get caught up. Now, some of you are going, but Mr. Sutton, we just simplified this right here. So this actually equals 1 over x plus b, as long as x doesn't equal b. Yes, it does. Congratulations. But I would rather not, how should I put this? I would rather not use the factored form just in case I bunged it. Face it, we all make mistakes. But let's just look at 0 is equal to x minus b for x squared minus b squared. And how do we get rid of our denominator? X multiplied by x squared minus b squared. So this simplifies to 0 is equal to x minus b. And then we add b to both sides. We want to solve for x again, so plus b, x is equal to b. Goody, except now you point out, what? We just said x can't equal b. So that doesn't work. Whatever it is, it has no x-intercepts. It's either above the x-axis or below the x-axis. Don't know, can't say anything about it. Now, the y-intercept, remember what I said about that? X equals 0. So y is equal to 0 minus b over 0 squared minus b squared, minus b over minus b squared, which is b over b squared, which is 1 over b, because my b's, some b's cancel out. And I go, okay, it crosses the y-axis at 1 over b, whatever b is. No idea. So far, so good? I'll take a moment to think about this, because I guarantee you're going to see this again. So pause the tape recording. When you're done, we'll go on and talk non-permissible values of x. So pause it, please. Welcome back. Now, non-permissible values of x, Remember, that's your denominator. X squared minus b squared cannot equal 0. So I add b squared to both sides. So x squared cannot equal b squared. Now that, think about it for a moment. You don't know what b squared is, but you can take the square root of both sides. So x cannot equal plus or minus b, whatever they are. So my vertical asymptotes, x equals plus or minus b. Okay. Now once again, I could put this as a domain question. X is all real, except x cannot equal plus or minus b. Is there anything else we can figure out? Well, actually, yes. One last thing, if we want it to be picky. Horizontal or oblique asymptote. This is y is equal to x minus b over x squared minus b squared. Now, what are my highest powers of x? Remember that? Right here it's x over x squared. So my numerator is x to the 1 divided by x squared, so it's not going to be oblique. I'm going to have a horizontal asymptote. This time I'm certain we have a horizontal asymptote, I hope. X goes to infinity. What happens? You look at the highest powers of x only. Y equals x over x squared. I get some x's to cancel out. I get 1 over x, which is 1 over infinity. Now, stop and think for a moment. What is 1 over infinity? 1 over any huge number is 0. So I have a horizontal asymptote at y equals 0. Okay. Now, that's the tricky part, trying to find, taking the equation and trying to describe the graph. In the last part, we're going to look at the graph and work backwards to figure out the equation. Review this. When you're ready, go on, and I'll see you for part 3.